Okay, okay, you're asked to find the critical points for this function right here, or the stationary points. And that's where the first derivative equals 0. So we're going to have to find the first derivative. Over here is a graph of f of x, this red curve. And this green dashed curve is actually the graph of the derivative. And you can see when the derivative is equal to 0, which there's a -3, we get a horizontal tangent line. And here, when the first derivative is 0, we've got a horizontal tangent line at that stationary or critical number. So how do you find the first derivative? Well, we've got the product of two functions, x cubed times e to the x. So we're going to use the product rule. One way to state the product rule is take the first function, x cubed, times the derivative of the second function. Derivative of e to the x is still e to the x, plus the second function, e to the x, times the derivative of the first one. Derivative of x cubed is 3x squared. And you might notice that each of these terms contains the common factor x squared e to the x. So if we factor that out, we're left with the binomial x plus 3. When does this equal 0? Well, when any of these factors equal 0. X squared equals 0, or e to the x equals 0, or x plus 3 equals 0. When x squared equals 0, x equals 0. That's one of the stationary numbers. E to the x never equals 0. I don't care what number you put in here for x, you'll never get an answer of 0. You actually never get a negative number. Okay, and finally, when x plus 3 equals 0, x equals -3. So what we're going to do is put these critical numbers, 0 and -3, on a little number line and apply what's called the first derivative test. So the -3 and the 0 are where the first derivative equals 0. Everywhere else has got to be either positive or negative. So we'll pick a test number in each interval. Like if you put -4 into the first derivative, x squared will be positive, e to the x will be positive, but x plus 3 will be negative. So the first derivative is negative everywhere to the left of -3. And you can see that on the graph. This green dashed line is below the x-axis. Between -3 and 0, pick a test number, like -1. If you put -1 into the first derivative, x squared is still positive, e to the x is still positive, x plus 3 is still positive. So between -3 and 0, the first derivative is positive. And finally, to the right of 0, same deal. Pick a 1, all the factors are positive. So when the first derivative is negative, the original function is decreasing. The tangent lines are going downhill. Between -3 and 0, since the tangent lines have positive slope, the original function is increasing, and so to the right of 0. So since at -3 we went from decreasing to increasing, we've got what's called a relative min here. At 0, the direction doesn't change. So this is not a relative max or a relative min. It might be a point of inflection. That's another topic. So f is increasing based on these arrows from -3 right here, all forever, all the way to infinity. Okay. Now, one of these days you'll learn the second derivative test, where we'll find f double prime of x and plug these critical numbers into the second derivative, and that will tell us relative max or min, and it'll also allow us to find what are called inflection points. There's probably an inflection point right about here, concave downward to concave upward. There's probably an inflection point right about there, concave upward to concave downward, and I'll bet 0, 0 is an inflection point. Concavity went from downward to upward. And I'll make note of the fact that the y-coordinate When x is -3, you put -3 in for x, you get -27 over e to the -3, or -27 over e cubed. Okay, there you go. Hope that helped. If you have any questions, post a comment.